your 1.8 notes that you're going to cut out. Today, 1.8 representing functions as graphs. So here, to go back to Hannah's question about, well, how do you know if you're going to draw the line or not? On this example, it says graph the function y equals a half x with a specific domain. So our domain is 0, 2, 4, 6, 8. How am I going to start graphing this problem? Any ideas on how we want to start graphing? Alana, do you have any ideas for this one, how we could start graphing? Very good. And so here is 0, 2, 4, 6, 8. Those are your domain numbers. So that's where those numbers are coming from. You're going to have blank tables. On this is your note, so I kind of showed you on the first one. You have your domain, and then Alana says we actually need to figure it out. So we're doing when x is 0, a half times 0. We get 0. I'm not going to do this every time, but you're just having some notes here to figure out. And then we have when x is 2, a half times 2. No, nice try. 1. And so that comes to 1.3 when we talked about the kinds of words of. The only time of is used is with fractions. So like a half times 4. Okay, half times 4. But if you say half of 4, that's the only time that the word of is used. Half of 2 is 1. Okay, finish the rest of the chart. Half of 4 is 2. Half of 6 is 3. Half of 8 is 4. And now we have our ordered pairs to be able to graph. We have 0, 0. That's the first ordered pair. When x is 0, y is 0. And then we have when x is 2, y is 1. So starting at 0, I go over to 2 for x, and then I go up 1 for y. X is 4, y is 2. When x is 6, y is 3. And the last one. So that's it for this graph. It gave you a specific domain. And so the only thing I want to see on my graph is that specific domain. When I draw a line, I'm saying that the domain also includes 1 in any fractions. It includes 3 in any fractions that are in there. If they didn't give you a domain, they say graph y equals 1/2 x. That's it. Just says graph y equals 1/2 x. You would pick your own domain numbers, and then you would draw a line here because you might have picked fractions or you might have picked other numbers that would be in between. That's when you want to draw the line, is when they don't give you a specific domain. But when they give you a specific domain, you can only have those numbers in the domain on your graph. Write a rule for the function represented by the graph. Identify the domain and the range. So we need to write a rule. Again, this is one of the harder parts of this chapter, would be to write a rule. And then identifying domain and range, that's pretty easy. For myself personally, I like to see a table of values with numbers in it. I just do better. So this is just about x and y. It's a generic problem. I see when x is 1, y is 2. When x is 2, y is 3. When x is 3, we have 4. And then 4, 5. And 5, 6. So I could say what my domain was. what the range is. Domain are my x values, so 1, 2, 3, 4, 5, least to greatest. In the range, 2 through 6. Now I just have to come up with a function rule. All right, the next thing would be to write a function rule. Function rules are always set up as y equals something of x. Something is happening to the x. Y is dependent upon x. So y always comes first. What's going on in this one, Hannah? So, yeah, this is a separate example right here with different data, right? The data is different than the table up top. What do you think, Alex? So if I look at my x's, how are they changing? They're going up by 1. If I add 1 to all of my x values, that would be true. And so just to reinforce what I was telling you on the activity that we did, here I could see that it's all changing. It's going up by 1. This was a very easy problem to do, but when it's not an easy problem, you want to have this technique. So here's the number that's being multiplied to my x, a 1x. And then if I look at the 0 number, which is why I always leave a space at the top in case I want to put 0 in, I could just work backwards, 6, 5, 4, 3, 2, 1. And it's a positive 1, so here I can see my plus 1. It's still true. I didn't have to do that, but I did it just to show you that when it is more difficult, then that's a good technique to have. So you don't have to use that technique when you can think of it, but when you can't, it's a good backup plan to have. And you will be using it in chapter 3 and 4, mostly 4. All right, ways to represent a function. We kind of talked about this in 1.7, which you will still be referring back to when it comes to functions. We have graphs with a vertical line test to tell if it's a function. We have ordered pairs, and we know if it has repeating x values, then it's not a function. Same thing with a table of values, exactly the same. And then we have a mapping. 4 ways to represent a function would be a verbal rule, the function rule. Oh, the function rule is here. So a verbal rule describes your equation or your function rule. We have a table of values, and again, just for looking at this, they're increasing by 2. That's why I can see a 2 in front of my x. It's increasing by 2. And if I looked at my 0 number, working backwards, 7, 5, 3, 1, it's odds, it's going backwards, it's going down by 2, so I could say -1. And again, you can see that that -1 is right there. So those 2 numbers are really key for writing equations and then graphing. 4 views of a function, which is what our activity was about. 4 different ways to look at a function. The last part for today's notes would be to determine whether a relation is a function. And that's just what I talked about from 1.7. I have a table of values. Does this table of values, this relation, is it a function? Is this first set of numbers a function? Why not? Not a function. Repeated x values. So it's only about the x. It's not about, doesn't matter about the y. How about the second set? Is the second set of numbers a function? What do you think, Emma? is the second set of function. Do we have any repeating x values? So it's a function then because there are no repeating x values. There's nothing wrong with that one. Function. So when they give me a table of values, I'm just looking at the x's. I wonder when they give me a graph, what is a technique for finding out whether or not the graph is going to be a function? Okay, so it is a discrete graph. That's true. They're not connected. How do I know if it's a function, though? What do you got, Hannah? Which number? So if I look at 3, how many x's equal 3? 3 and 5, that's true. They do have the same value. Is it an x value or a y value, though? Yes. So they do have 2 y values that are the same. Okay, so let's be reminded that when you do have a graph, find the way that you're thinking about it. But when you're given a graph, and I look back at 1.7, what technique should I be using if they give me a graph? What technique should I be using if they give me a graph? A vertical line test. Now, if you can look at it and you can say, okay, I don't have any repeating x values, that's fine. You did notice they had 2 repeating y values, but if I actually did a vertical line test on it, how many times did I just cross that point? Once. So is it okay? Is there anywhere I could draw a vertical line on here that it would cross twice? No, because there's no repeating x values. None of the x's are repeating, but we do see the y is repeating.
Wait, so if it's like there's 2 points on the same, like,
yes, when I do a vertical line, and if it hits it twice, then it's not a function. So this one is a function. There's nowhere I could draw. It's a function because it passes vertical line test. It's a function because it passes the vertical line test. Is normally how we think about graphs. Sometimes it's hard to see. Another thing somebody might do is actually write down the ordered pairs and just look at the ordered pairs to make sure there weren't any x's repeating. But that's a lot of work to go through, but it's still a technique. So there's nowhere I could draw on here a vertical line and it would touch something twice. What about the next one? Draw a vertical line. Is there any place I could draw a vertical line where it's going to fail the vertical line test? Where? At x equals 3. So here's my x-axis. If I draw the vertical line test here, how many times did that function touch the vertical line? 3 times. So it fails the vertical line test. It is not a function. It's only a relation. So not a function.